Hi everyone, this is lesson 5.3, solving quadratic equations by graphing and factoring. The objectives for today, you're going to be able to solve quadratic equations by graphing or factoring, and you'll be able to determine a quadratic function from its roots. The vocabulary for today: zero of a function, root of an equation, binomial and trinomial. All right, when a soccer ball is kicked into the air, how long will the ball take to hit the ground? The height, h, in feet of the ball after t seconds can be modeled by the quadratic function h of t equals negative 16t squared plus 32t. In this situation, the value of the function represents the height of the soccer ball. When the ball hits the ground, the value of the function is 0. So we're going to be talking about problems that you'll be able to understand all of this in just a little bit. A zero of a function is a value of the input x that makes the output f of x equals 0. The zeros of a function are the x-intercepts, and we often say when y is 0, what is x? So that's what you're going to be looking for. Unlike linear functions, which have no more than one zero, quadratic functions can have two zeros. These zeros are always symmetric about the axis of symmetry. In this example, we're going to be finding the zeros by using a graph or table. So the first thing I want to do is make sure that my equation is written in the standard form, ax squared plus bx plus c. And when I do that, I can label and know that my a is equal to 1, my b is equal to negative 6, and my c is equal to 8. Now, the first thing I want to do is check and make sure whether my parabola is going to be opening upward or downward. So I look at my a, and I see that my a is positive, and so that tells me that my parabola is going to be opening upward. All right, the next thing I want to do is find my axis of symmetry. So remember, the axis of symmetry is x equals negative b over 2a. So negative b is negative 6, so we're going to say negative 6 over, that's the cat, over 2a, which is 2 times 1. So we have a negative and a negative. That's going to make it a positive 6 over 2, which equals 3. So our axis of symmetry is going to be x equals 3. So I'm going to go ahead and graph that. Here's our graph, and there's my axis of symmetry at x equals 3. Now I need to find out where my vertex is, and it's going to be on the axis of symmetry. So I'm just going to fill in my x into my equation. So my equation says x squared, so I'm going to say 3 squared minus 6 times 3 plus 8. So 3 squared is 9 minus 18, that's a negative 9, plus 8 equals a negative 1. So my vertex is going to be found at 3, negative 1. All right, so let's plot that point, and there it is. All right, now the problem tells us to use a graph and a table. Okay, so in order to use a table, let's just go ahead and plot some other points. So what I'm going to do is make a little table. It's an x and y chart, and I know that my vertex is at 3, so I'm going to put my 3 down here, and I'm going to go ahead and try some other points. I'm going to try 1, 2, I know 3 is going to pair with negative 1, 4, and 5. Okay, so when x is 1, what is y? Well, 1 squared is 1 plus a negative 6 plus 8 equals 3. Okay, when x is 2, I have 2 squared, which is 4, minus 12, which is 8, plus 8 is 0. All right, and when x is 4, I actually have 16 minus 24 plus 8, and that equals negative, that equals 0 also. And then with 5, I have 25 minus 30, which is negative 5, plus 8 equals a positive 3. Okay, so now that I have some points here, I'm going to go ahead and plot them on. I've got my 4, 0 there, and on the other side, exactly symmetrical, is my 2, 0. And then here's my other 2 points. Now I can graph my parabola. Now the question says to find the zeros. So my zeros are going to be found right here at 2, 0, and 4, 0. So my zeros are going to be found at 2 and 4. So 2 and 4. All right. Why don't you try one on your own here? Turn your video off for a second and give it a try. Okay, hope you didn't find that one too difficult. Let's go ahead and get started. First thing, I'm going to write my equation in the standard form and go ahead and label everything. I know that my B is equal to -2, my A is -1, and my C is 3. Okay, so looking at my A, I see that my parabola is going to open downward. Next, I want to find my axis of symmetry, which is x equals -b over 2a. So my b is -2, so I'm going to say -2 over 2 times a, -1. So I've got 3 negatives, so that's going to give me a -1. 2 over 2 is 1, so my answer is -1. So my axis of symmetry is going to be x equals -1. So I'm going to go ahead and plot that. There's my axis of symmetry. Now, my vertex is going to lie on my axis of symmetry, so I'm going to just go ahead and fill in when x equals -1. So I'm going to say the opposite of -1 squared plus -2 times a -1 plus 3. So 1 squared is 1, but it says to take the opposite. So I'm going to have -1 plus +2 plus 3. So that would be 5 minus 1 is 4. So my y is going to equal 4. So my vertex is going to be found at -1, 4. So let's go ahead and plot that. There's my point at -1, 4. Again, it says to use a table. So I'm going to make my table. Have an x and a y, and my my axis of symmetry is going to be at -1. So I'm going to just put that down here, and I'm going to go ahead and put some other points. I'm going to try -3, -2, and just picking 2 numbers on either side of that axis of symmetry. And then this would be a 0 and a 1. Okay, so let's fill all these out. When x is -3, we're going to say the opposite of -3 squared plus -2 times -3 plus 3. That's going to be -9 plus 6 is -3 plus 3 equals 0. So when x is -3, y is 0. All right, for -2, to do all the math, I'm not going to waste our time on that, but the answer would be 3. -1 we already know is 4. 0 is going to be 3, and 1 is also going to be back to 0. So let's plot those points. Here they are. And we can make our parabola going down, and we can see that our zeros are going to be found at -3 and 1. Okay, when x is -3, y is 0, and when x is 1, y is also 0. So our x's are going to be at -3 and 1 when y is 0. Y equals 0. Okay, so next. All right, you can also find the zeros by using algebra. For example, to find the zeros of f of x equals x squared plus 2x minus 3, you can set the function equal to 0. The solutions to the related equation, x squared plus 2x minus 3 equals 0, represents the zeros of the function. All right, the solution to a quadratic equation of the form ax squared plus bx plus c equals 0 are the roots. The roots of an equation are the values of the variable that make the equation true. Okay, so notice that when you have a function f of x, we say that we're looking for the zeros. When we have an equation, we're looking for the roots, and I'm going to show that to you in just a second. You can find the roots of some quadratic equations by factoring and applying the zero product property. All right, so again, functions have zeros or x-intercepts, and equations have solutions or roots. That's just a technicality on the words. Just remember, zeros, x-intercepts, solutions, or roots are all when you're trying to, I just think of the zero, but they all mean the exact same thing, basically. All right, just a quick review of the zero product property. All right, if I have something that's equal to 0, 3 times 0 equals 0, so anything times 0 is going to equal 0. If the product of the two quantities equals 0, at least one of the quantities equals 0. So this is going to be a really important thing to remember. If one of these two equals 0, the whole thing equals 0, and that's basic. You learned it in 2nd or 3rd grade, but it's going to be really important now in Algebra 2. Let's try this example. Find the zeros of the function by factoring. So the first thing we want to do is go ahead and change it from x squared minus 4x minus 12 to set it equal to 0. So there we have x squared minus 4x minus 12 equals 0. Okay, the next thing we want to do is to factor. And to factor, we're going to find factors of negative 12 that add to negative 4. So what I like to do is make a big X. And I always multiply, this is a negative 12, and I have a 1 here, so I always just multiply these two together. Negative 12 times 1 is negative 12, and they're going to have to add together to equal negative 4. All right, and these have to be factors of negative 12, so I'm going to just start going through my factors of negative 12. I have a 1 times 12, and if one of them is going to have to be negative to get me a negative, but either way, when I add those together, 1 and 12, there's no way I'm going to ever reach up to negative 4. So I'm going to move down to my next set of factors. Let's try 2 and 6. Okay, so when I look at 2 and 6, one of them has to be negative, and so I think, okay, if the 6 is negative, negative 6 plus 2 is indeed negative 4. So I always go ahead and write it up here just to check. Negative 6 times 2 is equal to negative 12, so that's a check. Negative 6 plus 2 is equal to negative 4, so that's a check. So I know that I have it right. So now I'm going to put together and my equation. I'm going to factor it differently. So I'm going to have x and x inside my parentheses, and x plus 2. Okay, here's where I got my x plus 2, and the other one's going to be x minus 6, which I got from the other side. Okay, so now I have two factors that multiply together, and so I have now factored that equation. And now I'm going to think about this zero product property. If this piece times this piece equals 0, I know that one of these two has to equal 0. Either the x plus 2 has to equal 0, or the x minus 6 have to equal 0. So x plus 2, if that equals 0, then it doesn't matter what is over here. The whole thing equals 0, and same way the other way. So what I can do is say x plus 2 equals 0, or x minus 6 has to equal 0. So then I can solve each equation and see that x is either going to equal negative 2 or x will equal 6. So once we have found our zeros, then we can check and make sure that we got it right. So we're going to substitute each value into the original equation. So here they are. So we said that x was either going to equal negative 2, and when we put it all together, or x could equal 6. And we put them all together, we end up finding out that 0 equals 0, and that's true. And the other side, 0 equals 0, and that's also true. Here's another example. We're going to find the zeros of the function by factoring. So the very first thing we want to do is go ahead and set the function equal to 0. And next I'm going to look at these two terms, and I notice that both of the terms have something common in it. They both have a 3x. There's a 3x, and there's actually a 3x. It's the greatest common factor. So I'm going to factor out a 3x. And when I do that, I now can see that either 3x has to equal 0 or x plus 6 has to equal 0. So I'm going to apply the zero product property. 3x is going to equal 0 or x plus 6 is going to equal 0. So that tells me that x either has to equal 0 here or x has to equal -6. So now I have found my zeros. And of course we can check algebraically, and we can check by using your calculator. So when we check it algebraically, we end up seeing that they both equal 0 and they're both true, and that's correct. Or you can plot it on your calculator and you can also see. Try this example on your own to see if you're understanding it better. Put the video on pause and give it a try. Okay, hope you were able to figure this one out on your own. It says find the zeros of the function by factoring. So again, the very first thing we want to do is set our function equal to 0. Now when I look at this, I don't see any common factors, so I'm going to have to factor a different way. So what I'm going to do is I'm going to take a look at this, and I always change my minuses to plus the opposite. So here I'm going to say -6 times 1 is -6, and I have a -5. So I'm going to find two numbers that multiply together to get -6 and add together to get -5. So I'm going to start out with my 1 and times 6. And one of those has to be negative, and actually I can see that this is going to be the one that works for me. I can see that -6 times +1 add up to equal multiply together to get -6, and -6 plus a +1 gets me a -5. So I can see my factors right there. So I'm going to be able to easily factor this, x plus 1 times x minus 6. And next all I have to do is use my zero product property. This tells me that x plus 1 has to equal 0 or x minus 6 has to equal 0. One of those two has to equal 0. And so my x's or my zeros are going to be when x equals -1 or when x equals 6. And once again, we can check. So we're going to substitute our -1 and we'll substitute our 6. And when we do that, we find that 0 does equal 0 on both sides, so we know we did it correct. Here's another one for you to try on your own. Turn your video off and give it a try. Okay, this one says find the zeros of the function by factoring. So when I first look at this, the very first thing I need to do is set it equal to 0, set the function equal to 0. Now, as I look at this, I notice that there is an x and an x common to both of these terms. So I can see that I can factor an x out of this equation. And so it's the greatest common factor. So when I do that, it looks like this. And if you want to check and go backwards, you can FOIL it or just distribute. This x times x is our x squared minus an 8x. So you can see that the factoring it is the best way to do this. So now I'm going to use my zero product property. So this is telling me that either the x has to be 0 or the x minus 8 has to equal 0. And when I do that, I find out that x is going to either be 0 or x will be 8. So when y is 0, x is either 0 or 8. All right. And again, we can check it to make sure. We substitute each value into the original equation, substituting our 0, that's easy, gets us 0, and substituting 8 gets us 0 equals 0 also, so we know that we've done it correctly. All right, now our math is for all you sports enthusiasts. Any object that is thrown or launched into the air, such as a baseball, basketball, or soccer ball, is a projectile. The general function that approximates the height h in feet of a projectile on Earth after t seconds is given here. All right, so this formula is very common. You're going to see this on the SAT. You're going to see this in many places. So this number, -16 to the t squared, this is going to be our constant due to Earth's gravity. So if something is, if you have a projectile, it's going to have gravity affecting it. And so this is our partial part of the equation that's going to account for our gravity. This is our initial vertical velocity. And then finally, our h is going to be the initial height at t equals 0. So when t is 0 here, we have no gravity. When time is 0, there's no gravity pulling on our object. We have no velocity. So all we have left is our h, which tells us where we're starting from. All right? So sometimes we'll be kicking a soccer ball from the ground, and other times we might be on a building kicking the soccer ball off. So that's where our initial height is going to come into play. Note that this model has limitations because it does not account for air resistance, wind, and other real-world factors. So let's try an example using our new equation. The question says a golf ball is hit from ground level with an initial velocity of 80 feet per second. After how many seconds will the ball hit the ground? So let's remember our new equation, write the general projectile function. And here it is. And notice it says we have a vertical velocity, an initial vertical velocity of 80 feet. So remember, that's our V section. So let's go ahead and substitute 80 for our V here. So now we have our general projectile function, and we can just keep working with it. I'm going to go ahead and turn the page here. So the ball will hit the ground when the height is 0. So think about that. If it starts out and it goes up and it hits the ground again over here. So here's our starting point. Our ending point is at some time when our height is back to 0 again, okay? So let's, first of all, we want to set our equation equal to 0. And now as I'm looking at this equation, thinking, what can I do about that? I notice that there is a 16 here, and actually 16 times 5 equals 80. So I have a greatest common factor of 16t. So I'm going to factor that I'm going to actually factor out a negative 16t. All right, and so when I do that, I end up with negative 16 times t minus 5. So again, we're going to apply the zero product property. So that tells me that either negative 16 times t equals 0 or t minus 5 is going to equal 0. And when I solve, I see that either t equals 0 or t equals 5. So the golf ball will hit the ground after 5 seconds. Remember, T stands for time. All right, and notice that the height, we set our height to be 0. All right, so the height is also 0 when T equals 0, the instant that the golf ball is hit. And you could check it using your graphing calculator and see the zeros are at 0 and 1, 2, 3, 4, 5. All right. So here's another example that you could try on your own. It says a football is kicked from the ground with an initial velocity of 48 feet per second. How long is the ball in the air? So go ahead and turn your video off for just a second and give it a try. Okay, again, remember, we want to know how long t is it in the air. So that means the second it hits the ground, it's back on the, it's not in the air anymore, obviously. So we want to find the second it's going to hit the ground. In other words, when is our parabola going to cross our x-axis? When is it going to hit y equals 0? So let's write the general projectile function, and there it is again. We have an initial vertical velocity of 48 feet per second, so we're going to fill that in for our v. All right, and now the next thing we need to do is go ahead and realize that the ball will hit the ground when the height is back at 0 over here. And so we're going to set our equation equal to 0 because that's what we want our y to be. And then again, I can look here and I know that there's a negative 16t in both of these. So I'm going to factor out a negative 16t. And when I do, I get the following equations. And I can apply my zero product rule again. So I know that either 16 times t equals 0 or t minus 3 equals 0. So if I solve for those, I see that t is either going to equal 0 or t will equal 3. So is t going to equal 0? The time equals 0 here, and the time equals 3 at the end when the ball hits the ground again. So the height at both of those places, h, so this is our t on this side and h is over here, and we can see that the height is 0 when our t is the instant the football is hit and also the instant it hits the ground. And you can use your calculator to check and make sure that's correct, and if you put the equation in, you'll see that it graphs at 0 and 3. Quadratic expressions can have 1, 2, or 3 terms, such as just a plain negative 16 squared, or negative 16t squared plus 25t, or negative 16t squared plus 25t plus 2. So quadratic expressions with 2 terms are binomials, and quadratic expression with 3 terms are trinomials. Some quadratic expressions with perfect squares have special factoring rules. So you may remember this, that a squared minus b squared is the same as a plus b, a minus b. So if you were to actually work that out and go ahead and FOIL it back the other way, we would see a times a is a squared plus a minus b, that would be negative ab, and this is a positive ab, and then minus b squared. So when we work that out, we end up with a squared, and a negative ab plus ab goes away. It makes 0 minus b squared. So there's your rule. A squared minus b squared is the same as a plus b times a minus b. So that's a really important one to make your life easier if you can remember that one. All right, the perfect square trinomial is going to be another one that you can look at. If you look at the first term and the last term and see that they are perfect squares, and then you have a subtraction here, you look at this first term and last term, and if this middle term is the first term times this last term, or the first term times the last term times a negative 2, then you can automatically go ahead and write it out as a minus b squared. And if you see that your first term and your last term are both squared and the middle term happens to be 2 times the first and the last square and they're added together, we can use this one. And we'll see a problem here in just a minute that we can work it out. All right, let's take a look at some examples using these special factors. It says find the roots of the equation by factoring. So first thing I'm going to do is rewrite it in standard form. And now when I look at this, I know that 4 is a perfect square. I know that x squared is a perfect square, and I know that 25 is a perfect square. So I'm going to be able to use the difference of perfect square rule. So I'm going to write the left side as a squared and the right side as a minus b squared. So I see that this is 2x squared minus 5 squared. And now I can just do factor the difference of the squares. So it's 2x plus 5 times 2x minus 5. So now all I have to do is use my zero property rule. Remember, that tells me that 2x plus 5 is going to equal 0, or 2x minus 5 is going to equal 0. I just want to do this one out by hand just a little bit so you can remember, if I have 2x plus 5 equals 0 and I want to solve for my x, I can divide both sides. First thing I want to do is subtract both sides by 5, minus 5. So that leaves me 2x equals negative 5. Divide both sides by 2. I end up with x equals negative 5 over 2. I'm not going to rewrite it because I know you ran out of space on here. All right, and then the other way, I have 2x minus 5 equals 0. Add 5 to both sides. That leaves me with 2x equals 5. Divide both sides by 2. So I have x equals 5 over 2. All right, I'm going to erase all that. And if you need to put the video on pause and go back and review that, that's fine. So let's go ahead, and when you solve it, we get this. There's our equations that we get. And okay, here's another example using the special factors. First of all, it says to find the roots of the equation by factoring. So first thing I want to do is go ahead and rewrite it into standard form. I look at my 18, negative 48, and 32, and I don't see that those are perfect squares, but what I do see is that there's a 2 in each of those that I could factor out. So there's a common 2. It's the greatest common factor. So I'm going to factor a 2 out. So 18 divided by 2 is 9, 48 divided by 2 is 24, and 32 divided by 2 is 16. Next one I want to do is I'm just going to divide both sides by 2 to get rid of that 2, and 0 divided by 2 is 0. So I actually end up with 9x squared minus 24x plus 16 equals 0. Now I look at this and I say, oh, my 9 is a perfect square, 3 times 3. And my 16 is a perfect square, 4 times 4. And 2 times 3 times 4, 2 times my first term times my second term is indeed negative 24. So I have one of those special factoring. And so now that I see that, I can go ahead and rewrite it as a squared minus 2ab plus b squared. And once I do that, then I know that my factor, the perfect square trinomial, is going to be 3x minus 4 squared. All right. And the reason I knew that was a minus was because of this minus here. And then now that I can apply my zero product rule, 3x minus 4 equals 0, or 3x minus 4 equals 0, because there's actually 2 of them in there. So again, to solve for x here, we just say 3x minus 4 equals 0, add 4 to both sides. So now I have 3x equals 4, divide both sides by 3, and so I have x is going to equal 4 over 3. And there it is right here. All right. And of course we can substitute 4/3 in to check it. And sure enough, when you do that, you end up with 32 equals 32, and that's a true statement, so we know that we did it correct. Okay, try this one on your own. Turn the video off and then turn it back on when you're ready. So to solve this one, again, the very first thing we want to do is rewrite it in standard form. When I look at this now in standard form, I know that I have an understood one here, and that is a perfect square. So I have 1 times 1 is a perfect square, and my x. And then on this end, I see that I have a 4, which is a perfect square, 2. So, and I know that 1 times 2 is 4. So I get to use one of my special factoring for a perfect square trinomial, and that's going to be x minus 2 equals 0. And I'm going to just stop right here for just a second and tell you this kind of problem, to me, I generally don't use this perfect square trinomial, but I did teach it to you so that you would know it. But for me, just doing my X-ray general factoring, I always find the answer just as easily. So I know 2 numbers that multiplied together to get 4 and add together to get negative 4. Well, I know that's going to be negative 2 times negative 2 equals positive 4. Negative 2 times negative 2 equals positive 4. And negative 2 plus negative 2 equals negative 4. So I could have gone ahead and factored it out that way. Gets the same thing. To me, this method works easier, but this other method, rewriting it in a perfect square trinomial, also works just fine. All right, again, we're going to apply the zero product property. We get x minus 2 equals 0, or x minus 2 equals 0. Solve each equation, tells us that x is going to equal x equals 2. And then, of course, you can substitute 2 into the original equation to check it. And sure enough, when you do that, you find out that negative 4 does indeed equal negative 4. So that's a true statement. Try another one on your own, turn the video off, and then come back on and try it again. All right, so once you have tried it on your own, we look at this, and again, the very first thing we do is rewrite it in standard form. Looking at this, I noticed that 25 is a perfect square of 5, and x squared is a perfect square of x, and 9 is a perfect square of 3. So I can write the left side as a squared minus b squared. And once I've done that, then it's easy to factor. It's going to be 5x plus 3, 5x minus 3. We can apply the zero product property. So that tells us that 5x plus 3 equals 0 or 5x minus 3 equals 0. Solve each of those, and there you go. And again, we can put it in a graphing calculator, and you can find that your answer is correct. So if you know the zeros of a function, you can work backwards to write a rule for the function. In this example, it says write a quadratic function in standard form with zeros of 4 and negative 7. So we already know what the zeros are. We're just going to go backwards now. So write the zeros as solution for two equations, just like we did before. That's our ending step. Now it's going to be our starting step. So now rewrite each equation so that it equals 0. So x minus 4 equals 0 or x plus 7 equals 0. So we're just doing everything backwards now. All right, and then apply the converse of the zero product rule. So now we could just multiply these two equations together. And then just FOIL it out. X squared, x times x is x squared. X times 7 is plus 7x. Negative 4 times x is plus a negative 4x. Positive 7x plus negative 4x gives us our 3x. And negative 4 times 7 gives us a negative 28. So there you go. Now you have your new standard form equation, quadratic function. And then you could replace f0 with f of x, and you're done. And you could check it in your calculator and see that it works out. All right, one more for you to try on your own. Write a quadratic function in standard form. So turn your video off, give it a try. And so we start out with x is going to equal 5 or x is going to equal negative 5. We rewrite each equation so that it equals 0. Then we apply the converse of the zero product rule. Just doing everything backwards. Multiply that out by using your FOIL. And we replace our 0 with f of x, and there you've done it. So again, you can check it out on your calculator and prove out that you did it correctly. One last note that there are many quadratic functions with the same zeros. So each of these different functions actually end up having a 0 at the exact same place. So it's not just one function that can have zeros in the same place. They can look very differently. All right, so that is the end of our video today. As you can see, this lesson is going to be very helpful for you if you want to go into sports or improve your sports game. Dancers, football players, basketball players, volleyball players, soccer players, baseball players, all sorts of sports use the mechanics and the physics of math and science to help you improve your game. So if you are interested in this would be a really great thing for you to further your studies in. All right, have a great day. I'll see you soon. Bye.